Alright guys, next concept here is area of polygons. I've combined the next two concepts together just because they're pretty connected and pretty straightforward. So we're going to go ahead and start with just some basic formulas. I've got the three that we're going to look at here along with one other that we'll see. Most of these we've seen before. The one that we haven't seen is a kite. And so I'm going to just draw that one up here for you. So finding the area of a kite. So a kite looks like that. We take the diagonals of a kite to find its area. So the area of this kite would be diagonal 1 times diagonal 2. Okay, so that's our only new formula. Otherwise, we're still doing triangles, parallelograms, and trapezoids. So area of a triangle, 1/2 times base times height. The base of a triangle is one of its sides, and the height is the perpendicular distance from that base to the opposite vertex. So that looks different in many other triangles. In an acute triangle, if this is your base, then your height is the distance there. In an obtuse triangle, if this is your base, then it's got to be a perpendicular distance. So my height would be outside the triangle. Parallelograms, pretty straightforward, base times height. Your base is one of your parallel sides. The height is the distance between those two parallel sides. Trapezoids, 1/2 base 1 plus base 2. These are not exponents. They're subscript, meaning just base 1, base 2, not base to the first power, base to the second power. So we add those two up and then multiply it by its height. The bases are the parallel sides, and the height is the distance between those parallel sides. So that is the formulas that we're going to use in our polygons here. This is pretty straightforward. This should be pretty much review for you, but we do add in the kites. So I'm going to go through finding the area of a composite figure made up of different shapes here. And first of all, you can see that it's made up of a triangle, a trapezoid, and a parallelogram. So just you need to find the area of each of those. So my triangle is 1/2 base times height. My base is 2 or 6, doesn't matter, but I'm going to have 1/2 times 2 times 6. So the area of my triangle is going to be 6 square units. My trapezoid is 1/2 base 1 plus base 2 times the height. So my base 1 is 5, my other base is 7. So I'm going to say 1/2 times 5 plus 7. And then my height would be the distance between there. Well, if you notice, that split that in half. Half of 6 is going to be 3. So if I go ahead and do all the math there, go 1/2 times 12 times 3, really I'm going to end up with 18. So the area of that trapezoid is 18 square units. And then my parallelogram is just base times height. My base is 7, my height is 3 as well. So my area of my parallelogram is 21. And to find the area of that whole figure, I'm just going to add those all up. So I'm just going to go 21 plus 18 plus 6. And your total area then is going to be 45 square units. So pretty straightforward what we're working with here again. We do add in the trapezoids and the kites. But the formula for a kite is pretty straightforward. So the real new thing that we're adding in here is a regular polygon. So we are not used to working with finding the area of pentagons, hexagons, things like that. We can find the area of a regular polygon. A regular polygon just means that all the side lengths and angle measurements are the same. So each side length, each angle measurement is congruent in that shape. So I've got a regular hexagon here. and we're going to find the area. The formula for the area of a regular polygon is 1/2 times the A times P. And in this formula, A stands for the apothem. And the apothem is the distance from the center of your polygon to one of its sides. So I could have 6 different apothems here in this hexagon. It is the perpendicular distance. So that would be my apothem. Okay, so new term for you there, apothem. Perimeter, P stands for perimeter of that shape. So whatever my side length is, I'm just going to multiply that by the number of sides I've got. So whatever this side length would be, I would multiply by 6 to figure out the perimeter of that figure. So let's say that the apothem of this hexagon is 5, and the side length of it is 7. Just making up numbers here, just to show an example. To find the area of it, I have 1/2 times my apothem. My apothem is 5. A lot of people will make the mistake of just putting 7 in for P. P stands for perimeter, which means that all of these are 7, which means that I need the distance of all of them. I need the distance around the outside of the figure. So I have 6 of those, so I'm going to have 7 times 6, so my perimeter is actually 42. So then I can go ahead and find the area of that regular hexagon. So 1/2 times 5 times 42. I would just say, okay, half of 42 is 21, and 21 times 5, so my area is going to equal 105 square units. And that is how I find the area of a regular polygon, using the apothem.